Alright guys, so this is 5.6 that we're going to look at today. This is all on confidence intervals. This stuff is actually some of the more common stuff that you'll actually see throughout your lives. These are more common statements that you hear about in the news, see in the newspaper, stuff like that. It relates more to things that you'll see more in the media. Okay, so oftentimes, let's get into it with an example here. You're going to hear things like 80% of dentists recommend this toothpaste with results accurate within 2 percentage points 19 times out of 20. So you'll hear things like this in the news, or maybe, in politics it's quite common with, 40% of Canadians, if an election was held today, they'd be in favor of the Liberals, 36% Conservatives, 20% NDP, 2% Bloc Québécois, something like that. But then you always hear this within 2 percentage points and 19 times out of 20. So what we're going to do today is we're going to look into what that all means and figure that out. I don't know why that line does that. Okay? So when we interpret these results, we will consider things like confidence intervals, margin of error, and the confidence level. Okay? So your confidence interval, that's more like a range of values. Okay, I'm sorry, I don't know why that did that. Okay, it's a range of values. Your margin of error is always depicted with a symbol like this, and your confidence level is usually given as a percentage, okay, that you have to find. All right. Okay, anyways, it's a percentage that you have to find. Okay? So, let's get to the first term here. A confidence interval is an interval or range in which the true value is estimated to lie in, with a stated degree of probability, okay? So, your range here is based on things that you're given, and usually within a range with this margin of error notation, plus or minus. So that little T with two lines through it, that's actually plus and minus. So you're going to add and subtract the number. If you've ever heard the term like give or take 5 minutes, the plus sign's the give 5 minutes, the minus sign would be take 5 minutes. So if I said we're going to be leaving the school today on our field trip at 8 o'clock, give or take 5 minutes, so we could be leaving 5 minutes earlier or 5 minutes later. So anywhere from 7:55 to 8:05, okay? So if we go back to our dentist example here, we have 80% of dentists accurate within 2 percentage points, so that's our margin of error there, plus or minus 2. So my actual confidence interval or range that I'm looking at would be 80 plus 2 or minus 2. So 80 minus 2 would be 78. 80 plus 2 is 82. This is just earth-shattering mathematics here. So my confidence interval is actually anywhere between 78 to 82. Okay, so it could be maybe 78% of dentists only recommend this toothpaste, or it could be as high as 82. These are the possibilities, and that's what this statement within 2 percentage points is representing. All right, so margin of error is the possible difference between the estimate of the value we're trying to determine and the true value for the population. All right, or the true value. Scratch that out. And the true value, okay, usually expressed as a plus or minus, such as plus or minus 5%. So for our dentist example, our margin of error is plus or minus 2%, okay, right, 2 percentage points. Usually, there's not a whole lot of units used for margin of error and confidence intervals. It's usually as percentages, though. Okay, as we take polls and stuff like that, it's usually within percents. So don't worry too much about like units or anything like that. Now, your confidence level is the likelihood that the result is true. Okay, and once again, we usually state this as a percentage. You usually would like a high level of confidence. But sometimes depending on the poll, and this is what we kind of want to teach you guys is in this, in these polls is how accurate are these things. So if we go back to our dentist example here, we can see we have this statement at the end, 19 times out of 20, and usually you'll hear that at the end of a poll, like if you're watching the news or something, 19 times out of 20. So that's our level of confidence. We would say that this poll is accurate 19 times out of 20. So 19 out of 20, if you do the math real quick, is 95%. So we would say our poll is 95% accurate, which is pretty good. Anything under 90%, that's when you should start to be a little leery. Okay? So these are the general terms. I'm not going to ask you to define any of these on a test. You should just know how to work with the margin of error, find your confidence level, and the interval of confidence too, okay? So let's do a couple of examples now. Okay, so first example, a survey of 320 users of a skateboard park indicate that 40% of them would like the park's board to extend the evening of use for the facility. The survey is considered accurate within 5.4%, 19 times out of 20. All right, so we want to calculate the range of people that want to extend the evening use of the facility. So we know it's 40% of them, but we know our margin of error is going to be plus or minus 5.4%, not an 8. All right, so that's 5.4%. So what you would do is you would add and subtract 5.4% to 40 to get your range. So 40 minus 5.4, that's going to be 34.6. And if I add it, percent, whoa. Oh. $34.6, or it's going to be 40 plus which is 45.4%. So that's my range as a percentage, anywhere from 34.6 to 50 to 45.4. So, but because it asks for the range of people, we're going to use the amount here, and we're going to calculate actual amounts. So we're going to go 0.346 times 320, and we're going to go 0.454 times 320. So the first one would be 110.7, but you can't have 0.7 of a person, so we'd say that's 111. My next one would be 320 times 0.454, 146. So there would be my range of people. So this survey, based on this 5% margin of error, could be a difference of almost, of 35 people. So that's the range that you have to work with these surveys. Okay, so sometimes like when you have some surveys that have, 2 people, they'll say within the margin of error. That means that they're pretty close based on the give or take and the plus or minus. All right, now determine the accuracy of the results. Well, let's look at our level of confidence. Where is accurate 19 times out of 20. So 19 divided by 20 is just 95%. Okay, super easy mark there. All right, so next example. A poll was conducted to ask voters the following question. If an election were held today, who would you vote for? The results indicated that 53% would vote for Smith and 47% would vote for Jones. The results were stated to be accurate within 3.8 percentage points, 19 times out of 20. Who would win the election? So let's just set this up. We got Smith over here. I'm going to try to simplify this. We have Smith. We have Jones. For Smith, it was 47%, plus or minus 3.8. For Jones, oh, no, wait, that's the way around. For Smith, it's 53%, plus or minus 3.8. For Jones, it's 47%, plus or minus 3.8. So now our range here, for Smith, it would be, if you did 53 minus 3.8, that's going to be 49.2. And then if you added it, it's going to be 56.8. 56.8. And if we did that for Jones, that would be 43.02. And if we added that on, it would be 50.8. All right, so there's my range. So if we look at this, in all likelihood, Smith should win. He's higher in the polls within the month. But, right, because he's at 53%, Jones is at 47%. But if we look at the margin of error of 3.8%, on the high end of Jones here, he's at 50.8%. Right? That's the majority. And Smith on the low end is 49.2. So technically Jones could win if the poll is wrong within the margin of error. Okay, so technically Smith should win. We'll say he's the winner. But Jones could win. And this is what they say within the margin of error. It's too close to call. So this is what you see with very tight elections. We don't really see that here in Canada. I don't know how much politics you would follow in the States. But when you only have two people usually running for an election, it can be a little bit tighter. And this could happen. Okay? So that's why you have to check your range of data by adding and subtracting the values. Okay, example 3. Okay, polling organizers in Canada frequently survey samples of the population to gauge voters' preference prior to the election. People are asked, first of all, if an election were held today, which party would you vote for? If they say they don't know, then they ask, which party are you leaning towards voting for? This is quite common. So the results of the 3 different polls taken during the first week of November 2010 are shown below. The results of each poll are considered accurate 19 times out of 20, so we know right away our level of confidence is 95%, which is awesome. That 95% is not so much. All right, so here's the results of the poll. So there was 3 companies that did this poll. There's Nanos, Ipsos, and Ecos. All right, these are actual legit, or is it Ecos? Yeah, Ecos. Sorry, these are legit statistics companies in Canada. They do polling for. Their big time to shine is, of course, always during the elections, because they do polls like once a week. But they do stuff for other companies too. Like sometimes, you know, they could call and ask what types of brand of gum do you like to chew, types of coffee you like to drink, cars you like to drive, stuff like that. Or your thoughts on like environmental policy or different political policies and stuff like that. So, but they're quite busy, but during the election is when you see them all over the place. News organizations will hire them all the time. So, based on the 2 polls, or the 3 polls, sorry, the Ecos poll put the Conservatives and the Liberals tied at 29% each, the NDP at 19, the Bloc Québécois at 9, the Green Party at 11, and the Undecided at 12. Now, if we look here, Nanos at 37, 32, 15, 5, and 19.2, Ipsos 35, 92, 12, 11, 12, and the undecided were not available. But the real interesting thing here is the margins of error for each one are different, and that's also might have something to do with this. The sample sizes for each one are different. So the sample size would be the amount of people they polled. All right. So the Ecos poll, it sampled. They called it as many people as they could. They called about 18. They called just over 1,800 people. Ipsos was second with 1,000, and Nanos they came in last with 844. And that's how these polls work. When they do a national survey, they don't call every person in Canada. There's 35 million of us. That would take forever. What they do is they call a certain amount of people. They call about anywhere from 1,000 to 2,000 people from all over the country. Different portions, like they'd call probably the most people from Eastern Canada, like Quebec and Ontario, because that's where the largest percentage of our population is. And then, you know, they'll call a certain amount of people from the prairies, a certain amount of people from BC, so many people from Atlantic Canada, maybe 3 or 4 people from the north, just to get an estimate of what the national view is on things. Because you can't logistically call millions of people, but they can bang out 1,000 to 2,000 people within a couple days, and then crunch the numbers real quick. Okay, so if we look here, how does the sample size used in the poll affect the margin of error? So if we look, the bigger our sample size, the smaller our margin of error is, and that's usually what happens. The more people you call, the more data you collect, the more accurate your numbers are. So as sample size goes up, margin of error goes down. That's a down arrow. Okay. Let's compare the confidence levels for the Liberal parties for each of the 3 polls. How did the sample size used in the polls affects the confidence levels? So if we look at the Liberals, the first one was 29%, plus or minus 2.3. That was from the Ecos poll. So my range there is going to be anywhere from 26.7 to 31.3. Oh, it's a 31.3. My next poll, the Nanos poll, had about 32%, plus or minus 3.4. So that's going to put my data at anywhere from 28.6 to 35.4. So you can see your level, your mark, or your confidence intervals are getting bigger, which is not really what you want, because this is now 7 points difference here. They can be anywhere from 28 to 35%. So this can be going from the opposition, the official opposition in the House of Parliament, to 35.4% could put them at the majority. They could, you know, so it's quite a wide range. And then if we look at the IPSO one, lastly, which was at 29, plus or minus 3.1, you're going to get a range from 25.9 to 32.1. Okay? And that's how these work.